We're solving problem 21 from the 2022 F equals MA, exam B. Amora and Bronco are given a long, thin, rectangle of sheet metal. It has been machined very precisely so they can assume it's perfectly rectangular. Using calipers, Amora measures the width of the rectangle as 1 centimeter with 1% uncertainty. Using a tape measure, Bronco independently measures its length as 100 centimeters with 0.1% uncertainty. Which of the following are closest to the relative uncertainties they should report for the area and perimeter of the rectangle respectively? So, assume this is what a triangle or the rectangle roughly looks like. We are given the width is about 1, let's just say 1 centimeter for now, and the change in width over the width is 0.01. We can do the same thing for length. Length is equal to 100 centimeters. The change in length over the length is equal to 0.001 or 0.1%. So we have these variables now, and we can consider the area. The area of a rectangle, here I'll just write this out. Area is equal to length times width. But since you're considering the uncertainty of this, since they're not measured, we can say, or we can rather find the change in area over the area is equal to the square root of when you square these changes, like change in width over width squared plus change in length over length squared. Basically we do this to find the uncertainty of this event because this is evidently how you add the two together. It's gonna be very small of a number, so you can just like roughly estimate. On the test, it just has like small percentages. So we have this. This becomes, well, this is the square root of 0.01 squared plus 0.001 squared. Square that. And this is, well, when you square these basically round to 0.01 or 1%. Now we want to do the same thing with perimeter. Formula for perimeter of a rectangle is 2 times W plus L, width and length. So first we want to find the change in the perimeter for the uncertainty of this specific case. So we have delta P is equal to 2 times the square root, and these are just the changes. So you're basically like moving forward a decimal point, I guess you could say it that way. So this is delta W squared plus delta length squared, and then you take the square root of that. So delta P is 2 times the square root of, this is 0.01 squared plus 0.1 squared. So we then get that, well, inside this is about 0.1 centimeters out of the square root, So when you multiply 0.1 centimeters by 2, you get 0.2 centimeters. So delta P is roughly 0.2 centimeters. You have to divide by the real value to find the uncertainty of this, in this case, the uncertainty of like the measurements, So delta P over P is equal to, well, we just solved for this. This is 0.2 centimeters divided by the real value of the perimeter, 2 times 100 plus 1. These are also in centimeters. And what this roughly turns out to is, well, this becomes 0.1 after you cross out the 2, 0.1. And then 0.1 divides by that, by 100 about, is roughly 0.1%, or 0.001. And why we write it in this form, 100 plus 1, is because since you want to estimate, you can say that this one doesn't exist because it's so small of a change. And since you're dealing with powers of 10, it would be just easier to divide like this. So now you just want to find the relative uncertainties of the area and perimeter. You get that this is 1%, 1%, this is the area to the 1%, and 0.1%, that's the perimeter. So that is our answer for this problem, and if you're wondering, that's answer choice B on the test.